Okay, so we're going to do two examples. Here is the first one. So I know that this is a hyperbola. How? How do I know that this is a hyperbola? Because it's a minus. That's exactly right. There's a minus sign in the middle. Okay. It's still showed up over here. You can see it's picking up my voice right here. Okay. So, yes, I know it is a hyperbola because it has subtraction in there. So now I'm going to go look at my two equations, and I'm going to see if I can figure out if this is a vertical or a horizontal hyperbola. What is the difference in standard form for vertical and horizontal hyperbolas? Yes, sir? Right. So if the x comes first, like it does right here, that is a horizontal. And if the y comes first, it's a vertical. So look at this one. The x comes first. That means this is going to be a horizontal hyperbola. Cool. So step number one said to make sure that it is in standard form, and this is in standard form. Step number two was to graph the center being HK. So HK are the numbers that are in parentheses, and we don't even have parentheses here. So what does that tell us about the center? It's the origin. Very good. The center is at 0, 0. Okay? Then the next thing that we're going to graph are the vertices. And the vertices are found, just like they were with an ellipse, by getting A and B. So in a hyperbola, a squared rather, is always the number that comes first. So a squared is going to be 4. And that means a is 2. Square root of 4 is 2. Now, since this is a horizontal hyperbola, we're going to count 2 units to the left and the right for a. So I'm going to go 2 units this way and put a point. That point is at 2, 0. And I'm going to count 2 points the other way. Oops, not there. 2, and that's going to be negative 2, 0. So there's my two vertices. And I knew that I was going to count left and right because I knew that this was a horizontal hyperbola. I'm going to do the same thing for the co-vertices, but using our b squared value, which is 9. If b squared is 9, then b is 3. And so from the center, which is at 0, 0, I will count up and down 3. So I go up 1, 2, 3, and put a point. So I have a co-vertice at 0, 3. And then I'll count down 3 as well to get the other one. That's a co-vertice at 0, negative 3. And what I pointed out on your note page is that once you have the vertices and co-vertices drawn, you can do this box using the vertices and co-vertices as your points. And this box is going to help us draw the asymptotes. So there's that box right there, using the vertices and co-vertices as our edge pieces. Okay, the last thing we do before we actually draw those asymptotes is we find the foci. So let's do that. And the formula for foci is exactly the Pythagorean theorem, a squared plus b squared This is another difference between a hyperbola and an ellipse, because an ellipse was a squared minus b squared. This is a squared plus b squared. And we know what a squared and b squared are. A squared was 4, and b squared was 9. So c squared is 13, which means c is the square root of 13. And the square root of 13 is 3.6. Okay, so that means from the center, I count 3.6 units left and right. These are going to be beyond the vertices, and that's okay. That happens in hyperbolas. So we count 1, 2, 3.6 units. That'll be one of the foci at 3.60. And then we'll count 3.6 the other direction. Negative 3.60. And there's our foci. Now, if all we were asked to do is graph this, we could put the asymptotes on right now. The asymptotes are going to go through the corners of our box. So I can do one asymptote going through these two corners, like this. And then the other asymptote would go the other diagonal through the other two corners. And this is enough for me to graph it. If I was asked to find the equation of the asymptotes, I have to do a little bit of algebra. We'll do that in just a second. But if all I needed to do was graph it, which a lot of times that is all you're asked to do is graph it, all you have to do is make sure the asymptotes go through the corners of that box that we drew. And this is good enough to do kind of a sketch of what it should look like. So it's going to go right along this asymptote down to the vertex, and then it'll come along the other asymptote just like this. So there's one piece, and then the other one will go the opposite direction. Come right down along the asymptote, hit the vertex, and then go out this way. And there's our graph of a hyperbola. Doing these on Alex, which is where your assignment will be, graphing them on Alex is really, really easy because Alex has a hyperbola tool, and all it asks you to do is put 1 point at the center, 1 point at the vertex, and then put 1 point on the corner of the box, those 3 points, and then it draws it for you. So Alex makes it really easy to draw the hyperbolas. You just have to know those 3 points. Doing it on a graph like this obviously requires a great deal more work. So here it is graphed, but let's suppose, just for the sake of argument, that you had a mean teacher that gave you a question that asked, hey, what actually are the equations of those asymptotes? Let's say you had a mean teacher. I'm not saying you do have a mean teacher, but let's just pretend like you did. I know it's been a while since you've had one, but just use your imagination. So if I go back up to my notes, here's the equation for the asymptotes for a horizontal hyperbola. Y equals plus or minus. And the reason it's plus or minus is because we have two asymptotes, one with a positive slope and one with a negative slope. So b over a and then x minus h plus k. Okay. So it's y equals, and we're going to have b over a times x minus h plus k. That'll be one of them. And then the other one will be negative b over a, x minus h plus k. We have two asymptotes, one positive and one negative. And these asymptotes for this equation are really super easy because what were our h and k? 0. They were both zeros. So we don't even need the h and k on this one. Those just go away. And then we figured out that a was 2 and b was 3. So it'll be 3/2 x minus 0 plus 0, which of course is just 3/2 x. And the other one will be exactly the same, only negative. Negative 3 halves x minus 0 plus 0, which is just negative 3 halves. And there are two asymptotes. So if somebody said, listen, I don't care about the graph, I just want to know what the equations for the asymptotes are, that's how you find them. I don't think any part of this is particularly difficult. I think the math on this is really easy, but boy, is there a lot. There's a lot to do for hyperbolas. In addition to center, foci, vertices, and covertices like we had to do for the ellipse, we now add in asymptotes, which is another level of difficulty. So these are ellipses, but then way more on top of that because we got to do the asymptotes. Okay, so I said I was going to do two examples. Here's the first one. The second example I want to show you is how does it change when it's not centered at 0, 0. So let's take a look at this second one. It's still in standard form, but it is now not centered at 0, 0, and let's talk about how that makes it different. Just like last time, the first thing that I want to establish is this going to be a horizontal or a vertical hyperbola? It's horizontal, how do you know? Because the x is in the first fraction. The first fraction is always the positive one, and the second fraction is always the one after the minus sign. So I guess if you had an insanely mean teacher, they could do negative y minus 2 squared over 16 plus x minus 3 squared over 25. That would be really mean, though. Even your teacher can't be that mean. I enjoy crying children, but I don't want to break you. So let's... I already have. So this is a horizontal hyperbola because the x comes first. And the first thing that we want to graph is the center. Where is the center in this one? It's at 3, 2. Very good. The h is 3 and the k is 2. So center at 3, 2. So over 3 and up 2, and there's our center. Oh, I'm sorry to say, I think the graph paper I gave you is going to be just slightly too short for this one. Ah, well. Okay. So now we got to figure out where the vertices are. And the vertices come from our a squared value. A squared is 25. A squared is always the one that comes first, no matter what. A squared comes first. So that means A is 5. Because this is a horizontal hyperbola, I count 5 units left and right from the center. So 1, 2, 3, 4, 5. That point looks like it's 8, 2. And 1, 2, 3, 4, 5 in the other direction is negative 2, 2. So there's our two vertices. And then the exact same process for the covertices, except using b squared and going up and down. So covertices, b squared is 16, which means b is 4. So from our center, we go up 1, 2, 3, 4. That point is going to be at 3, 6. And also down 1, 2, 3, 4. And that point is going to be at 3, negative 2. So there's our covertices. Once you have the vertices and the covertices, you can draw your box that will get the asymptotes for you. So we use the vertices as the markers for the edge. So here's the box that all the center stuff goes in, and the asymptotes will go through the corners of the box. Okay. Before we do that, though, let's find our foci. Which are found by doing a squared plus b squared. And we know from the problem that a squared was 25 and c squared was 16. So c squared is 41. That means c is the square root of 41. Which is 6.5? 6.4, I think. 6.4, 6.5. Doesn't matter. Okay, so from the center, we count 6.4 left and right. And this is the part where I said your graph paper is going to be a little bit too small. So I count 1, 2, 3, 4, 5, 6.4. So my first foci is going to be at 9.42. And then 1, 2, 3, 4, 5, 6.4. This direction will be negative 3.42. There's our foci. Just like on an ellipse, the foci aren't necessarily part of the curves we're going to draw, but foci are how you get the hyperbola in the first place, is you connect the foci and draw, like I showed you with the ellipse, you connect like basically a string between them, and that's how you draw the hyperbola. Okay, let's put our asymptotes on here. Asymptotes go through the corners of our box. So from here to here. So there's one. And here's the other one. And on one side, we're going to be able to just barely put the parabola. And on the other side, we got a little bit more room. And there it is. It's so beautiful. I love him. Clearly. Don't try to misgender the hyperbolas. You can clearly see that's a boy hyperbola. Strong, confident hyperbola. Any questions?